Hi everyone, welcome to the sixth lesson for topic 4.4 Newton's laws of motion. So for today's lesson is going to be the same learning outcome as well, which is how to apply Newton's laws of motion in the situation given, and you need to solve the problems which model as the motion of connected particles. So previously we talked about the vertical pulley system. So for today we will be looking at pulley system again, but with a horizontal surface. Okay. So yeah, that's the idea for today's lesson. So let's start with the very short introduction. Alright, so this is a force diagram that we'll be looking at for today's lesson. So you'll realize that it's the same pulley system as the previous one, which you have a smooth pulley, then two particles at both ends. But it's just like previously, you have two particles hang freely in a vertical motion, right? So for today's lesson, one of these particles is placed on the horizontal surface. So normally it will be a table. Then after that, the smooth pulley is at the edge of the table. Then the other particle is like hangs in freely. Okay, so yeah, we'll be looking at the force diagram. Then we'll try to label all the forces. Then we try to write down some equation that will be helpful for us to solve the question later. Okay, so yeah, let's try to label all the forces involved here. So yeah, we know that there will be a vertical force. So let's try to write down this is our weight 1, then our weight 2. So since this particle is placed on the surface, so we know that there will be a force that exerted by the surface onto the object as well. So which is going to be the normal reaction force. Okay, so for this particle is not get in touch with any surface, so that's why there's no R involved. Okay, so this two particle is connected by this smooth pulley system. So we know that for the light inextensible string, we have the constant tension. All right. Okay, so for this surface, right, normally you'll be given like two circumstances. So the first one is either it's a smooth one, so which means there will be no friction. So the other one is there will be friction if let's say it's a rough one. So I'm going to use a different color here to actually note the frictional force that opposing the motion here. Okay, so what happened here is that I want you to try to think of for the previous pulley system, right, we'll always look at either which particle is heavier, then after that we can know that what is the motion of the particle. I mean, what's the motion of the whole pulley system. So it will tend to accelerate towards the direction where the particle is heavier. Okay, so for this situation, right, let's try to draw how is the combined system is going to look like. So this is our first particle. This is our second particle. So pulley system at the middle, right? Then this is our second one. Okay, so let's try to draw two, one with friction, then one without friction. So first one, the second one. Okay, so now let's try to imagine both of these particles is actually connected by this pulley system, right? So we have tension involved and which they will tend to cancel off each other. So I hope that you still remember how to do the combined system. Okay, then after that there will be a force that moving to the right, which is the weight here, right? So this is W2, W2. Okay, but now when you try to look at the object one here, you'll realize that weight one is actually not in the direction where we try to combine. So this is like in a vertical direction. So that's why when you try to draw it, right, your W1 is actually going down. So that's not going to affect anything for our direction in a horizontal motion. So that's why, what else forces do we have here? So it's either if let's say there's no friction, there's nothing more here. So if let's say there's a friction, then it will be something like this. Okay, so now you can imagine, right, there will be only two situations. So the first one here is if let's say there's no friction, then obviously there's going to be motion over this direction. Am I right? Because the weight 2 is the only forces that exert on the whole combined system here. So for the second one, it's either depends on what is the frictional forces here. So which means if WA is big enough to overcome the friction, then the pulley will actually move on that way. Then after that, if the friction here is actually big enough to actually exert resistance here, then which means the particle will not move. So it's either it will be at rest, or the second one is there will be a motion going over here. Okay, so it's the same thing if let's say you try to use your common sense, right? So normally if you have these two particles that plays in like this, So it's either that this particle is like very, I mean, the weight will always balance off with the normal reaction. So that's why if the frictional, so we know that the frictional force is actually mu r, right? So what is the r here is actually the weight. So it will kind of like depending on what's the weight here as well. So which in common, if we, let's say we know that the weight, the mass of this particle is like a very heavy one, then obviously there's no going to be any motion for this pulley. Then if let's say the weight for this particle is like a very heavy one, then this pulley will just move in this direction. So you can just remember that for every motion that involved, right, if let's say there's acceleration that involved, normally it's in this direction. It's not normally, it's impossible for your pulley to move in this direction. Okay, so yeah, you can kind of like remember that. So now we'll be writing down the equation that involve here. So if let's say we are doing a combined system, so which means there will be two equation. We try to write down one with friction and one without. So the net force here, if let's say if it's without friction, then which means what happened here is that you only have W2 will be equal to the mass 1 plus your mass 2 and then multiply A. Okay, so net force equal to MA. So if let's say that is a friction, then which means it will be W2 minus of the friction, then equal to same thing, the total mass multiply the acceleration as well. Alright, so the A is towards that direction. Okay, if we try to look at it as a separate system, so let's try to solve the most easiest one, which you have this. Okay, so that's why we have our normal reaction will be always equal to our weight 1. Alright, so there's no resolving forces that will be involved lah. So normally all the friction, I mean, yeah, because of we are trying to looking at the motion in this direction, right? So that's why there will not be any slanted angle and so on. So you are not going to do any resolving here. So the next two will be, let's try to look at here. So which means you will have W2 minus of the tension. Okay, then it will be equal to M2, then acceleration. Alright, so the acceleration will be the same, yeah, because they are on the same, I mean, because the string is always taut, so that's why how fast this particle move is going to be the same thing like how fast this particle move as well, because of the pulley is a smooth one also. Then the second one for the particle one is going to be because the acceleration is happen in this direction, so that's why the tension minus of the friction, then it will be equal to mass 1 multiply acceleration. Okay, so these are the few things that we'll be using of. So you can see that we can always use a combined system to solve our A first. Then after that, we can do a separate one to get our R. So, oops, I'm sorry. If let's say that's friction involved, then you might need to actually write down your R first. So you can use mu R here. Then after that, you can use the combined system here to get your acceleration. So if let's say you need tension, then only we'll try to do the separate one. Okay, so I hope that you can see the difference for the equation here. So the same thing will be using Suvat formula as well. So the friction force and also the net force equals to Ma. Alright, so we'll be looking at three example here with two past year questions. So I think the two past year question is very helpful, especially the last one. I think yeah, there's some special situation there, and it's like a 9 marks question. So I think that is good for us to go through together. So whatever that you see in your exercise is the easier one. Yeah, so we can try to discuss the harder question here. Alright, so let's try to look at example 1. Okay, example 1, a box with mass 3 kg is placed on a table. Okay, so which means there's a table here. So this is the box. So mass of 3 kg. So the weight here is 30 Newton. Okay, so we can try to write down the normal reaction here as well already. Okay, so the coefficient of friction between the box and the table is 0.5. So we know that this table is a rough one. So a string is attached to the box and passes over a smooth pulley. So there's a string here. So a smooth pulley. Okay, then after that, the part of the string between the box and the pulley is a horizontal. Yeah, so you can see a horizontal string. After passing over the pulley, the string hangs vertically. Okay, with another end attached to a ball of mass 2 kg. So which means here you have the weight of 20 Newton. Alright, so the system is released from rest. The question wants us to find out the tension of the string, and then after that, there's some given information about, I think it's a Suvat one. Then after that, you need to find out the height of the table. Okay, so yeah, we can try to write down something first. So which means here you have friction. Okay, and then after that, tension moving inwards. Alright, so by looking at this question, you know that if let's say you want to find the tension, which means you must need to do the equation in a separate, in a separate way for particle 1 and particle 2. So that's why we need to use the F equals to mu R, so it will be easier for us to actually find out what's our normal reaction force first. So yeah, you can straight away look at it from the force diagram, but we are just going to state it here. So the R here is equal to 30 Newton. Alright, so that's why we can try to find the acceleration, because later when we use F equals to ma, then you'll need the A to solve your tension as well. So by looking at them as a combined system, so that's why the net force is 20, then minus off the frictional force here, then it will be equal to the total mass. Okay, and then multiply the acceleration. So 20 minus of mu is 0.5. Normal reaction is 30, equal to mass 1, mass 2 is 2 kg, and then plus 3 kg and acceleration. Okay, so from here we can solve that 5a is equal to 5, and that gives us a is 1 meter per second square. So after we get this, then you can choose either one lah. So normally we try to use this, then it will be, it's easier for us to see, right? Because we already know that the acceleration towards this direction, it will be your A. So in this situation, then we have 20 minus of t, it will be equal to the mass for the ball, which is 2, then acceleration is 1. So we can get t equal to 18 Newton. So you should be getting the exact same answer if you try to do tension minus of F equal to 3 times acceleration as well. Okay, so now that's it for A. Yeah, I think that's easy. So the ball is initially 8 cm below the tabletop. The ball hits the ground after 1.2 seconds. So the box has not reached the pulley at this time. So which means that it's still in, because what happens if the ball reaches the pulley, right, is going to affect the normal, the normal motion for this ball. So that's why the question need to tell you, when you try to look at the previous past year question, they tell you similar thing as well. So yeah, this is your ground. So the ball actually hit the ground after 1.2 seconds. Okay, then after that, the other thought, so I try to draw the ball here. Alright, then after that, the question gives us that the ball is initially 8 cm below the tabletop. So which means from the tabletop here onto this part, the length here, okay, is 8 cm. Alright, so now what do we need to do so that we can get the height is that we have the time here, right? So we need to find what is our displacement here. So by adding up with the 8 cm here, then we can try to get our answer. So please bear in mind that this is 8 cm. So yeah, later when you try to get your answer in meter, then you should, convert one of them. Okay, so now let's see what do we have here. So the question say that it's released from rest. So that's why some information that we have is the initial velocity is 0. Then we get our A from part A already, right? So acceleration is 1. Is given the time is 1.2 seconds. So we want to find the displacement. Okay, so U, A, T, and S. So we can get S equal to UT plus 1 over 2AT square. Okay, so 0 plus 1 over 2AT square. So by just doing some simple maths here, then you can get 0.72, and this is meter. Okay, so when you write down your height, make sure that either you answer it in cm or you're answering it in meter. So the height here is going to be just now is 8 cm, right? So let's try to change it to cm then. 72 cm, then we can get our answer 80 cm. Okay, so it's alright as well if you want to answer 0.8 meter. Alright, so that's it for number one. I think this is very simple for you to have an idea on how everything is look like. Then after that, we move on to number two. Alright, number two. So this is a question from paper 42, March 2016. Yeah, so two particles A and B of masses 0.8 kg and 0.2 respectively are connected by a light inextensible string. So particle A is placed on the horizontal surface. Okay, so particle A. So the string passes over a smooth pulley P fixed at the edge of the surface. So this is the pulley. Okay, so that's a string here. Then after that, B hangs freely. So that's why particle A, the weight is 8 Newton. Then after that, we have one more particle B hangs freely here. Okay, then the weight here is 0.2 kg, which the weight is 2 Newton. Alright, then the horizontal section of the string AP is of the length of 2.5. So this is particle A, right? This is particle B. So this is P. Let's try to label here, I think. So A, then this is B. Alright, so the length for AP is 2.5. So which means here is 2.5 meter. The particles is released from rest with both sections of the string taut. Okay, so given the surface is smooth, find the time taken for A to reach the pulley. So yeah, which means it's a smooth surface, so that's why there's no friction involved. So we can try to label the other force. So the normal reaction, the tension. Okay, so since there's no friction involved, then I think we do not need to state the normal reaction here because we are not going to use it in any way. So yeah, we can straight away look at the combined system, then we try to find the acceleration. You also do not need to find tension in this question because of the question want you to find out the time taken for A to reach the pulley. So which means it's going to be like a Subart question which you have S, you have initial velocity, then you will need to find your acceleration so that you can find what is your time. Okay, so that's why we can straight away solve it by using a combined system. So that's why 2, okay, is our net force, right? There's no other forces here, so that's why 2 is our only force. So 2 will be equal to the total mass 0.2 plus 0.8, then we can find our acceleration. So we can get 1 here, so that's why A is equal to 2 meter per second square. So after we get this, then I think we can solve out Subart. So it's released from rest as well. So the total displacement is 2.5. Alright, then after that, what else do we have? Yeah, A equals to 2, so we need to find our T. So USAT, then we can use the formula S equal to UT plus half AT square. Alright, so 2.5 equal to 0 plus 1 over 2, A is 2, and then time T square. So 1 over 2 times 2, so it's just T square equal to 2.5. So from here, we can find our T is square root 10 over 2, which we try to change it to 3 SF, then it's 1.58 second. Okay, so yeah, you might want to save this value instead, in case you need to use it in part 2, yeah, so you need the exact value, right? Okay, so part 2, given instead the surface is rough and the coefficient of friction between A and the surface is 0.1, find the speed of A immediately after it reaches the pulley. So you can see the idea will be the same thing. So what do you need here is the new acceleration as well with a new forces exert here. Okay, so that's why it's very straightforward also. So which means you are trying to use the exact same thing, which is a U and a S, then you just find out your new acceleration because of that is a frictional force. Then after that, we can get our V. So you do not need to find tension as well. Okay, so that's why it's very important for you to know how to do the combined system one. Then I guess that would be like very simple and it's easier when you try to solve some of the question, especially like this. Okay, so this is for part 2. Let me try to write this maybe. All right, so for part two, there's a friction involved here. Okay, so yeah, the coefficient of the friction is 0.1. So we can try to write down our R first. So the normal reaction will be equal to 8. So that's why you can straight away write down your F if you want, then equal to mu R. So it's 0.1 multiply the normal reaction, which is 8. So we can have 0.8. Okay, so now let's try to resolve it. So, sorry, not resolve. Yeah, I mean, put them in a combined system, then we try to solve it. So we have 2 minus of the frictional force, which is 0.8, equal to the total mass is 0.2 plus 0.8. Then we need to find the acceleration. Okay, so a continue one is kind of easy already. So A is 1.2. Okay, so you should be realized that the A here it will be a smaller answer compared to your one because there's a friction opposes the motion, right? So that's why if you get a bigger number than your number one, then that's something that you might need to check it off already. Okay, so U is 0, A is 1.2, S is 2.5, then we want to get our final velocity. Okay, so V square is equal to U square plus 2AS. So 0, 2, 1.2, 2.5. Okay, and V square is 6. So when we try to solve for V is equal to positive, negative, right? But just that we know that our acceleration is in. I mean, your direction of your motion is moving down, so that's why your velocity should be a positive one. So our V is positive 2.45 meter per second. Okay, so that's it for number two. I think this is easy as well. So let's try to look at number three. All right, number three. So if you already know know the idea, right? You can always try the question out first. I think this is very interesting. So you can try out yourself. Then after that, check your answer. It doesn't matter. Okay. So yeah, particle A and B of masses 0.3 kg and 0.7 kg respectively are attached to the ends of a light inextensible string. So let's try to label the weight. So have A, which is 3. Then for B is 7. Okay, so the particle A is held at rest on a rough horizontal table with string passing over this smooth pulley fixed at the edge of the table. So B hangs vertically at a height of 0.5 meter above the floor. So the system is released from rest. Okay, so which means the U is equal to 0. And after 0.25 seconds, the string breaks. Okay, so this is what makes the questions like more interesting. Yeah. Okay, so A does not reach the pulley in the subsequent motion. The question want to find out what is the speed of the B immediately before it hits the floor. Okay, so which means what's your final velocity here? All right, so let's try to label the other force. So yeah, surface, so the object. So we have normal reaction. So tension moving inwards. Alright, so let's try to imagine what kind of motion that involve here are. So which mean that what do you have is that you have your normal acceleration, which actually caused by the tension. Am I right? Okay, let's try to look at B, then we try to draw what happened to B then. Okay, so which mean at the first stage, right, what happened here is that B actually moving a little bit lower here. So this is for the 0.25 second. Am I right? Then after that, what happened is that after 0.25 second, then the string breaks. So after the string breaks, then only the only the particle here drops to the ground. Okay, so this is like the two stages here. So this is the acceleration that actually caused by the tension, right? Because the string doesn't break yet, so that's why the string is taut. So the motion is actually because of the tension of the string and also I mean the weight, so which mean by the whole command system. Then after that, for this stage, right, what is your acceleration involved here is going to be your gravitational acceleration because the string is break now. So that's why there will be no tension anymore. So the forces here is actually based on like a normal free fall. Okay, so I hope that you can see this is a multiple stages question. Okay, so let's try to see what kind of information do we need. So if let's say we need to find the last stage, right? So which means we have our v already. So since we already know what is our acceleration, which is going to be our g, so let's try to write down here. So a is 10. Okay, so can we actually find out all the others? So you have either you need to get your initial velocity, which is a final velocity here, right? After that, the other thing is you need to get your time and your displacement. So among these three, you will realize that we wouldn't able to get time from the previous stage, right? But we can get our displacement because by knowing how much they move in the first stage, actually we can use 0.5 to minus off the displacement, then we can get what is our s here. Then after that, the initial velocity for your second stage is basically the final velocity of your first stage. So we can try to find our u first. So you can see there's two unknown that you need to get from the first stage. So that's why it's the same thing. If we need to get our u here, which means for the first stage, we need to get what is our v. And then we need to get what is our s. So since we already know the t, which means the time here is 0.25 and we have the whole system, right? Then we can try to find out our a. So this is like our planning for the problem solving. So you can see that because there's a lot of unknown that you need to find out. So that's why this is like a very a question with very high marks. Okay. So yeah, let's try to solve the acceleration first. So since there is friction involved, right? I'm sorry, I think I left out. Yeah. So the coefficient of the friction. So that's why we have this F. Okay, so there's friction involved. So that's why for us to solve the A, then which means we need to get our normal reaction for force first. So number one, part one. Okay, so the normal reaction is basically equal to 3n. Okay, so we can straight away write down our F here, so depends on you. If not, then we can straight away solve from the complete system. So 7 minus of the frictional force, it will be equal to mass 1 plus mass 2, and then multiply the acceleration. Okay, so what do we have here is 7 minus of coefficient is 0.2. So R is 3, mass 1 is 0.3, mass 2 is 0.7, and we get A. So by solving this 0.3, 0.7 is A as well. So 7 minus 0.6. So we have 6.4 meter per second square. Okay, so after we get this, then now what else? Yeah, we get our A already, right? So now let's try to see whether we can get our S first or we can get our V first. So I think we need one more information, right? Because you do not have S and V. So, oh yeah, the system is released from rest. So that's why at this part, the U is actually equal to 0. Okay, so we have 1, 2, 3. We have 3 information already. So now we can solve our S and V. Okay, so yeah, U is 0. The time involved here is given in the question, which is 0.25 seconds. Then we have acceleration equal to 6.4. So from here, we want to get what is our V and also what is our S. All right, so now we need two different equations. So let's try to solve the V first. So U, T, A, and V. So we can use V equals to U plus AT. So 0 plus 6.4, 0.25. So from here, we can get 1.6 meter per second. Okay, then after that, S. So please try to use the original information lah. So I mean, if let's say this is wrong, then you might not want to use the wrong answer, right? So always use the information provided if that's possible. So U, S, A, and T. Okay, so we can use U, S, A, and T. So S is equal, yeah, S will be equal to UT plus half AT square. So 0 plus 1 over 2, A is 6.4, the time is 0.25. Okay, so by solving this, we know that the total displacement is 0.2. So something that you might need to be aware of is that this number should be a number that is lesser than 0.5. So if let's say you have the number here is bigger than 0.5, then you might know that something is wrong already. Okay. So now we have all this information already. So I think we can try to write down here. So let me try to use a green color. Okay, so this is the answer for all this. So we have u, we have our u already, right? So u is 0. So our a here involved just now is 6.4. So s here is 0.2. Then v is 1.6. Okay, and this is going to affect the u here, so which is the u will be actually equal to 1.6 as well. Okay, then after that the s will be equal to 0.5, then minus of 0.2. Then we can try to do the working here. So I try to use a different color to do the second stage. So what's the color I use? Yeah, so this is for the second stage, so which mean when the string breaks. Okay, so string breaks here. Alright, so for strings break, then the V will equal to the U in front, right? So it's 1.6, the direction is still the same. Then after that, the A is under gravitational force, so it's 10. So it's a positive, yeah, because it's moving down now. Then after that, what else do we have? Yeah, or S is equal to 0.5 minus 0.2. So as long as you are using information that you cannot read from the question, please write down your working. So what we need here is the question want us to find out what is the speed, right? So that's why we are finding our V. Oops, I'm very sorry, this is our U. Okay, the initial velocity for your second stage is the final velocity of your first stage. So this is U. Apologize. Okay, so yeah, U, A, S, and V. So we can use V square equal to U square plus 2AS. Let's write down the information. So U square is 1.6 to 10, 0.3. So from here, then I can get 8.56. So square root the answer. Then we can get 2.93 meter per second. Okay, so this is very important now because some of the students you might forget about this. Then what you will try to do is the s here will become 0.5. Then your answer is wrong already. Okay, because for the 0.25 second, there's some distance involved as well. So that's why you should use that one to minus off your first stage. Okay, so number 2, the question want to find out the total distance traveled by A. Okay, so yeah, this is a question that is trying to trap the students as well. So I try to use the other color here. Okay, so what happened here is that you see, right, for the first 0.25 second, because of A and B is still connected by this Pulley system. So what is the distance that moved by particle B is going to be the exact distance that moved by A. Am I right? For the first stage. So which means for this purple color one, so that's why the S here, maybe the A will actually move to, let me try to erase this. Okay, so the A will actually move to here for the first stage. Am I right? So how much B move will be exactly how much A move. So that's why the distance here will be 0.2 as well, because they are connected by the string, and the string is always taut. Then after that, for the second stage, right, what happened here is that when the string breaks, so do you think this particle is still moving? Yeah, because the forces actually cause that there will be a final velocity for this stage, right? So the final velocity wouldn't be, suddenly disappear when the string breaks. So which means what happened here is it will exert it will not exert any more force, but the remaining forces here is going to affect the motion of this particle here. So that's why the final velocity here is not yet 0. So it will actually continue to move because of the initial velocity, and the friction here is not big enough to actually suddenly stop everything. So that's why the particle here will actually continue to move, but the motion here is not caused by the gravitational force like what happened here. Okay, because the motion here is going to this direction, right? So how can this, affected by the gravitational force? So what is the force involved here? So you have what is the initial velocity over here is something that you need to get. So yeah, this is like what's your u. Okay. Or for the second stage, it should be what is your v. So which means what is your u here lah. Okay, then after that, we need to find our new acceleration, which caused by the only force left, which is the friction. Okay, so now let's try to write down some information before break first, because we know that they before the string breaks, they are moving in the same acceleration. So that's why their initial velocity is all zero, right? So their final velocity should be the same. So let's try to write down the information. So this is for part 3. I'm sorry, this is part 2. Yeah, okay. So before the string breaks, okay, then for the motion, what happened to A is that the distance is actually equal to the distance of particle B, right? So that's why the S is 0.2. Okay, then after that, we also know that what is a final velocity is exactly same with particle 2 as well, right? So that's why what you have here is, remember, it's not this one. This one is after your acceleration due to gravitational force. What you want is the final velocity for the first stage, so which is 1.6. Okay, so now after the string breaks, okay, so what we want to have here is the initial velocity is 1.6, right? All right, then after that, what else do we have? We want to get the final velocity is 0, so we want to get what is the total displacement for the second stage. So you'll realize that you do not have your t, you do not have your a, so that's why we need to get our a first. Okay, so how to do our a? So for the stage here, like what I mentioned just now, the only force that exerted on this particle, because the string breaks already, so that's why there's no more tension. So the only thing that exerts here is the friction, which opposing the motion of this particle. So that's why it's going to be negative friction equal to MA. Okay, so negative mu R 0.2 and the R just now is 3 Newton equal to the mass for the first particle, which is 0.3, then multiply acceleration. So from here we can get 0.3 A is equal to negative 0.6. So A is equal to negative 2. Okay, so you're supposed to get a negative answer because that's like very, I mean, in a common sense, you know that the ball is trying to move in a slower rate, right? Then after that, only the ball will stop. Because if let's say this acceleration is a positive one, which means this particle will, I mean, forever move inwards, move forward, then after that, it wouldn't be reaches a velocity of 0 at the final stage. So yeah, negative 2. So now we can do our equation already. So v square equal to u square plus 2as. So 0, 1.6 square plus 2, negative 2, and we want to get our s. So 4s will be equal to 1.6 square. So you see it's a correct one as well because we get a positive s. Yeah, okay, because we know that the thing will actually move forward. So that's why your s should be a positive number. All right, so after we get our S, so yeah, remember you are counting the total displacement. So you need to get the displacement before the total distance, okay, before the string breaks and after the string breaks. So that's why 0.2 for the first stage. After the string breaks, we have 0.64. So add them up together, then we have 0.84 meter. Okay, so that's it for number 3. I hope that you can understand the idea. Yeah, so it's actually about string breaks. Then you need to understand you need to identify that there's 2 different stages because the acceleration involved is different. Then you will need to solve them separately lah, basically. All right, so that's it for today's lesson. So yeah, spend some time to do your revision and so on. And yeah, I'll see you in next week's lesson. All right, thank you.